Good day, everyone. Today we're going to solve problems in Chapter 5, Fundamentals of Fluid Flow. So, the problem is a pipeline is made up of pipes that are 0.350 meters, 0.290 meters, and 0.240 meters in length. Calculate the mean velocity in each size of pipe with a constant water flow of 250 liters per second. So let's proceed to our figure. So the figure might look like this, and this is a theoretical image that we have formed. So it flows different sections. So in our section 1, it has a big diameter. So it has a bigger open space. So in the section 2, we have a 0.290 meters of diameter. So it became smaller. Until to our section 3, it have a smaller diameter, so the open space became smaller also. But the flow of the water is uniform all throughout the section at 250 liters per second. So it means that we will have a difference in terms of velocity. So now let's talk about our givens. So to have a uniform of units, we will convert 250 liter per second to cubic meter per second. So we all know that 1 cubic meter is equivalent to 1000 liters. So 250 divided by 1000, and we will have a 0.25 cubic meter per second. So our first diameter is 0.350 meters, our D2 is 0.290 meters, and our last diameter is equal to 0.240 meters. So in continuity principle, at any instant, the flow at any section of the stream is constant. So as I said earlier, even the pipe will become smaller. The flow or Q is equivalent to all section. So in formula, we will have a Q is equal to Q1 is equal to Q2 is equal to Q3. So it's like 250 liter per second is uniform all throughout the section. So this will be. So velocity have a different value since they have a different property of diameter. So now we will proceed for finding the velocity of every pipe. So first is for our pipe 1. So flow is equal to area times the velocity. So our Q is 0.25. So Q1 is equal to 0.25. So it is equal to pi over 4, which is our area, is equal to pi over 4 times the diameter, which is 0.350 squared, times the velocity. So if we calculate this, we will have a value of our first pipe, which is the velocity of pipe 1, which is 2.60 meter per second. So now we will proceed for our pipe 2. So Q2 is also equal to 0.25. So 0.25 is equal to pi over 4 times the diameter of our pipe 2, which is 0.290 squared, times the velocity. So it have no difference in the flow, right? But the area and the velocity only has changed. So now, if we calculate this, we will have a velocity that we are looking for. So the value of our velocity of our pipe 2 is 3.78 meters per seconds. And for the last, we will get the same flow. So Q3 is equal to 0.25. So 0.25 is equal to pi over 4 times the diameter of pipe 3, which is 0.240 squared times the velocity of our pipe 3. So if we calculate this, we will have a value of our velocity 3, which is 5.53 meter per seconds. So this will be all the velocity that we are looking for each every pipe. So no matter how different the diameter is, the flow or Q or the volume flow rate is equal all throughout the section. It is just the area and the velocity that exchanging according to continuity principle.